All right, here we are. Yes, sorry that I'm late. It was one of those things, it's a Monday and what do you want? It happens. But anyway, so today we're going over the sample midterm. And when we're done with it, we should be done today. I don't think it's that long. Then I can post the actual midterm, and then you can have, let's say, a week to do it. Let's say what I usually end up doing is giving you, let's say, normally what I would do is have you send it in by midnight next Monday, which is the 18th. And by far, you'll have plenty of time to do it. But you never know. I mean, other things might pop up. This way you can take your time and go through your notes and do whatever you have to do. And as we discussed before, what you'll need to do is either scan it with an app on your phone, or else use a physical scanner. If you have a printer, it may have a scanner attached to it, or else just take pictures of it with your camera phone and email them back to my purchase account if possible. And just before you send them out, just one thing, make sure that they are legible, because if I can't read them, I can't correct them, can I? No. And sometimes people don't realize, like when you're taking a picture of a document, it's a little bit different than what you're used to, because there can be glare that you don't even notice that's making it hard to read it. So just be careful. When you take the picture, just look at it. If it looks fine to you, it'll be fine. And then send it back to me. Now, if the files are too large to send as a single email, you can break it up into different emails. Like you might have to send it in 2 or 3 different emails, and that's fine. But if you're going to do that, though, what you should probably do is mention that in your email, that you're doing this in multiple emails, because otherwise I may not realize that you're trying to do this. And if I can't read something, or if I can't find your work, I'll just write to you and let you know. Because sometimes, in spite of our best efforts, emails with large attachments simply don't get delivered, and I may not find out about it. Okay. I know that it might go in my junk box, but sometimes it doesn't get delivered at all. And that makes things a lot worse, because then I have no idea what happened. So we'll work on that together, but I'll let you know if there's a problem. And because no matter what happens, almost without fail, there's always a problem with email and large attachments. It's just, the technology still isn't perfect. And so there's always a chance that something could go horribly wrong. But anyway, when you look at it, you'll see that it's pretty much exactly the same as what we've been doing. There's no surprises in there. If there's any question in there that you're not clear about, you can always send me an email and I'll try to help you understand what it's all about. Especially the word problems. Sometimes I think it's been written clearly and maybe you're not so sure about that. So you always have the opportunity to ask me questions about, to clarify the questions, not to tell you the answers, of course, but to clarify the questions, just in case the way I've written it is not crystal clear. All right, so let's do it. Let's get this thing going. Now, if you've been looking at it, you'll see that it's really just the same. There's nothing new here, but it is excellent practice to do this one more time. Go through this material and hold on 1 second. Oh, I'm in the wrong one. God, no wonder. Yeah, that was a little nerve-wracking. There we go. Okay, so let me save this. And what I'll do, of course, as usual, is I'll post the solutions on Moodle along with the actual midterm. All right, let me just get this saved. Today's the 11th. There we go. All right, let's do this. So first things first. Now the factors. Now remember we did this. The factors. Now this does not mean necessarily the prime factors. That's something different, all right? So don't get confused between factors and prime factors. Prime factors are the ones whose product equals the original number, but they're all prime numbers. Here, we're just looking for all the pairs of natural numbers whose product is equal to 60. So what you can do here is write them out in a list. In my opinion, this is the best way to avoid missing one of them, because that's really the biggest challenge, not missing one of them. So basically what you need to do is go through all the natural numbers and see if they work. Now this one happens to have an awful lot of factors, as you can see. So once we get to 6, now 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 works, but 10 is already there. Okay, so there's no need for me to write 10 comma 6 when I've already got 6 comma 10. So that means we're done. So you can write them out as a list if you choose to do so. Either one of these is fine. Wow, it's a lot of factors for such a small number. 1 through 6, 10, 12, 15, 20, 30, and 60. Very good. Now the factors of a prime number, by definition, are 1 and the number itself. Okay, so for example, 13 has the factors 1 and 13. Nice. All right, now the least common multiple. Now remember how this works. Common multiples mean, well, first of all, multiples mean you're multiplying a number by all of the natural numbers. 1, 2, 3, 4, 5, 6, 7, etc., etc. Same thing for 7, 14, 21, 28. And when you notice that you found one that they have in common, they will have more than one in common, but what you're aiming for is the smallest one that they have in common. And so in this case, the answer is 21. The greatest common factor. Now that's the fun one. Remember, we get to draw a tree for this one. And let's see. Hold on, there it is. So let's do this. So remember, you stop when you only have prime numbers. And there's many ways of doing this, but you'll always end up with the same prime factors, no matter how you approach this. So for 24, the prime factors are 2, 2, 2, 3. And for 36, you can see from the chart, or the graph, that they are 2, 2, 3, 3. Oops. So what we're looking for are the ones they have in common. Since the 24 and 36 both have the prime factors 2, 2, and 3. Yes, they both have 2 2s and they both have at least 1 3. The first 24 only has 1 3 though. So therefore, the greatest common factor is the product of these, which is 12. Okay, and you can double check there. I mean, you can see clearly that 12 evenly divides into both 24 and 36. There is no other number which is larger than this, for which this is true. Okay, so that's that one. E, a composite number. All right, well, you know what? You can define this in a few different ways. Let's just say that a composite number has at least one factor other than 1 and the number itself. You could also say that it is a number that is not prime, which technically is correct because all the natural numbers have to be one or the other. But I think this is more precise. This gives us an exact clue as to what it means. It just simply means you've got at least one factor besides one in itself. Now, this one is a bit tricky. What is the smallest prime number greater than 30? Well, you know what? That means you really should just make a list. And sometimes this is a nuisance. You have to think about each one individually. There we go. Well, it is the answer is 31. Now, it's possible that Symbolab has the capability of doing prime numbers. I don't know. I've never thought to look at it. It doesn't seem like that's what it's meant for. But I bet it can do that if we look hard enough. Let's just quickly check this out. Ooh, boy, I don't know. That seems like a bit of a stretch. You know, I'll tell you, let's do this. Let's go to the internet. Somebody's bound to have instructions for it. Can Symbolab produce prime numbers? Oh my God. Well, you know what? How does this work? Look at this. I'm not sure how this works though. You see, here it is. Prime factorization. Let's check this out. Ooh, look what we discovered. The only problem is I'm not seeing any instructions here. See, it's like it has prime factorization, but I'm not getting the point of this. Let's see. Oh, I don't know. That's not helping. Oh, I'm so disappointed. No, you know what? I'm not sure now. Now that I'm looking at this. All right, I'll tell you what. Let's try this one. Okay, well, guess what? It worked. Oh, there it is. Look down here. It's doing the prime factorizations and it's giving you the answer. Look at this. This is amazing. How about these common multiples? We had 3 and 7 before. 21, of course. The only thing I'm not so sure about is, all right, let's try factors at 60. Oh, I don't know if it understands that. No, that it doesn't seem to work with that. I'm not so sure I'm getting, oh, no wonder we didn't type the right thing. Well, all right. But primes, it's one to do prime factorization, I think. I don't see it listed there. I'm not so sure about that one. I thought it would be able to give us a list of, let's say, the first 10 prime numbers. I'm not seeing that though. Let's try this. There's always good old Google. Well, there it is. Look at this. Let's try 15. Well, there it is. Man, it's going to get to the point eventually where you don't have to do anything for yourself. I'm not sure if that's a good thing. 2, 3, 5, 7, 11, 13, 17, 19, 23. No, we got them all. All right, well, there's a little hint how you can at least double check your results. You should really ideally do these by yourself, but You can use that to double check your answers if you need to. All right, now, how about these? Simplify. Now, SimpleLab might be able to do this, but so often it does not do what you think it's going to do, because there's different ways of doing this. I wouldn't overly depend on technology like SimpleLab, but it's nice to have it as a backup, because it sometimes does things that you're not expecting. And, you know, like I said, there's often multiple ways of getting to the same answer, and it may not follow the steps you're expecting. But here, all we have to do is say, well, listen, let's break this up into factors. And let's see if we can find factors that might be perfect squares. Here we did find one. And we're done. That one was easy. Now this next one is a little tricky. It isn't immediately obvious, but there's a perfect square in here. It happens to be 144 times 2. Now, if you didn't notice that right away, what you need to do is break down into factors until you find ones that enable you to simplify it. Eventually, you'll get to the same point. But it's easier if you notice the perfect square right away. Okay. All right. Now, this next one is kind of interesting. Now, remember, we did say that you may not add radicals unless there's the same number under the square root sign. Now here, that's true, but we can simplify it a little by doing this. If you notice, 4 radical 4 is just 2. So we've got 3 radical 2 plus 8, which by convention, we would normally write as 8 plus 3 radical 2. We usually have the constant on the outside here, and the radical comes afterwards. It doesn't really matter. It's just a convention. If you put down 3 radical 2 plus 8, I'm not going to take any points off. But normally we do try to write the constant first. Okay. Now, remember, with multiplication, this is very straightforward, because what you're doing is you're multiplying the coefficients and these radicals by each other. Now, in this case, it just so happens that 91 is prime, so you can stop right there. And you know what? Since we have the technology, let's come back here. Where was that? Oh, wait, no, it isn't. Sorry, 91 is not prime. What does it divide by? Hold on a second. There it is. You know what? It turns out that it's equal to 7 times 13, but since that doesn't help, so it's not prime, but it's 13 times 7. But since these are both prime numbers, breaking it up will not do you any good. So you should just leave it like this. All right. So in other words, you might feel like, oh, well, you know, look, we can break it down into 13 times 7, but that doesn't help because they're both prime numbers. All right. And now what about this one? Now remember the way this works with division. So I moved the 2 on the outside. This is actually the same thing as 1/2. Actually, let me do this. I've kind of skipped a step. Let me do this. And so in other words, you see this 2 down here. And now I can rewrite this 48 over 3. Oh, now this one's turning out rather well. So it's just 2. I think you'll agree that's a lot simpler. Wow. Sometimes you never know what's going to happen when we simplify this stuff. Very good. Now, here's some exponents. Everybody likes exponents because they're so straightforward. And if you can't figure them out, you can type these into your calculator. All right. Just be aware that if your calculator gives you a fractional value, it is going to give you a decimal and not the actual fraction. I don't think your calculator can convert decimals into fractions. That would be nice. And some of the high-end engineering calculators can do that. Like if they see 0.11111, they can convert that into 1/9. This one, well, let's find out. Let's try an experiment. Suppose that you get like, all right, now I'll tell you what, let's wait for the second one. The first one, we don't have to worry about. 3 to the 0 power is just 1. Because any number raised to the 0 power is just 1. Just remember, x to the 0 is 1. Now this one is the same as 1/4 squared. Now you can leave it as 1/16, or you can go ahead and calculate that out if you want to, and you'll get 0.0625. But here's the interesting part. Suppose you ended up with an answer of 0.0625, and you wanted to figure out what decimal that was equal to. If you take in your calculator, this is, I'm just throwing this in there because you may need this one day. If you take 0.0625 and you go to your calculator and you hit the key 1/x, which is way over in the extreme left-hand side, the result will be 16. So what that means then is that this shows that 0.0625 equals 1/16. All right, now nobody asked you to do this, but I just wanted you to be aware of this capability in your calculator, just in case it turns out to be very useful. All right, I just wanted to throw that out there. Now, this next one, you'll see, remember, this is the power rule. This is 3 to the 6th power, not 3 to the 5th, 3 to the 5th, because you're raising one value to an exponent, and 3 to the 6th is equal to 729. On the other hand, if you look at this next one, this one is equal to 3 squared, 3 to the 2 plus 3 power. And so this time, 729, 3 raised to the 5th power is 243. All right, so make sure you understand the distinction between those two cases. Now, this one involves division. And remember how that works. This is going to be 4 to the -2 minus 3, because that's what's in the denominator. 4 to the negative fifth, 1 over 4 to the fifth, or you can rewrite this as 1 over 10^24, which if you want to turn that into a decimal, although you don't need to, it's a small number, 0.0000976, let's say. So that's fine. 1 over 4 to the fifth is fine. 1 over 10^24 is fine. 0.0009766 is fine because they clearly all mean the same thing. Now is where the fun begins. These fractional exponents. Now, your calculator is capable of doing these. This one in particular, your calculator has a cube root function. This is the cube root. And if you go to your calculator, you'll see that that key is right there. Let's see where it is. Yes, it's in the third row, third column, which means type 3. And then the button you need is this one. Oh, wait a minute, sorry. No, you don't put 3 there, you put 8, sorry. This calculator, this would be 8. 8 cube root, and that's it. You don't even need to hit the equal sign, just it comes out with a 2. So in other words, what they're saying here is that the cube root equals 2 because 2 cubed is 8. Okay, so in other words, there are just 2 different ways of expressing the same result. Okay. Now, oh boy, look at this one. This is the same thing. This can be approached in different ways as 1 over 27 to the 1/3 power, or 1 over the cube root of 27. So what can you do here? Well, what you can do, in my opinion, your best bet is to go to the calculator, leave the 1 in the numerator, and go to the calculator and ask for the cube root of 27. 27 cube root, and it's 3. And that's it. I mean, if you want, you could write it as 0.333. Now, if you didn't know this, what you could have done is use the general exponent key. The only thing you have to watch out for is what to do with that negative. And every calculator handles this differently. So what we're going to do is this. Wait, hold on. I have to try it myself. I don't use this calculator a lot, so I have to find out what exactly it's doing here. Oh, I see what it's doing. Okay. I think, yeah, that should do it. Now, this is a separate key. This switches the sign. This is, of course, division. This is my equal sign. So if you try that, you'll get the correct answer. Now, the calculator, like I said, it's going to show you 0.333. But if you then hit the 1 over x key, that'll turn it into 3. So you know that this is 1/3. Okay, so if you want to double check. So here's what you need to do to get the answer. 27, x to the y, open parentheses, 1 divided by 3 negative close parentheses equal. This is the part you need. Unless you want to follow along in the top, like you did in the top. In other words, just replace the denominator with the cube root of 27 and you're all set. Either way, you'll get the right answer. All right, now this one is really tricky. You can do this directly in the calculator. Let me just show you what exactly it means though. It's actually the cube root of 64 squared. So one option you have in this calculator is you can type 64x squared Now that will result in 4096, which you then apply the cube root function to. And you should get 16. All right, now the other option is to do 64 x to the y power, open parentheses, 2 divided by 3, close equals. That should do it. So 64 x to the y, open parentheses, 2 divided by 3, and you'll get 16. Now, I would encourage you to learn the second technique because you can do this with any exponent you have. The one above requires us to be able to use the cube root function, which if you don't have a cube root, then you'll have to do this one anyway. So in other words, this one does not depend on any particular buttons except the exponentiation button. Okay, so I think you're better off learning how to do this approach. The one above will work, and that's fine, but for what if it's like the 3/5 power, for example? That's not going to work. There's no button in here what gives you a 5th root, so you might as well use this approach. All right, now that those are done, scientific notation. Well, this is interesting. Now remember how this works. You need a number where the first decimal, the first digit is before the decimal, the rest come after. So it's 1.245217 times 10 raised to some power or other. Well, how can we figure this out? Well, one way to do this, a graphical way, is to say, well, listen, in order to take this number and turn it back into the original value, I would have to shift this decimal point 1, 2, 3, 4, 5. Wait a minute. What? Oh, I did something wrong here. Sorry, this is 0.17. Let's try that again. 1, 2, 3. Here we are. Now we're done because the original number was 12,452.17. So I shifted it 4 places to the right to get to the original number. And that means that this exponent is 4. Whoops, hold on. Now, here's another possibility. Your calculator has this button here called EE. And so what you can do is type that number in, 1.24 5217. Now, if you hit let me just do this, 1.245217. If you hit the EE button on the calculator, and then you hit, let's say you're not sure and you try 4 or 3, let's say, you hit 3 equals, you'll see that you've got the wrong number. And you'll say, oh, it's 1,245.217. Let's try that again with EE4. And you can just go through them all. 1.245,217 EE4 will give you the right number. You can try that. That's a possibility. Or, like I said, keep trying different values, but you know that it has to be a number larger than, the exponent is larger than 1. Now, another way to think about this is that 1.245217 times 10,000 equals the original number, and 10,000 is 10 to the 4th. So that means that your original expression must have been okay, 1.245217 times 10 to the 4th. So there's a lot of possibilities. You have to pick the one that makes sense to you. That's the bottom line. Now, can Symbolab do this? Probably. Let's find out. Okay. Let me just check something. Oh my God. All right, let's try it. 1,200, let's see, no, what was it? 12,452.17. All right, let's give it a whirl. Why, what do you know? It's right there. So you can use this, to double check your results. You should still do it on your own, but, double check it. And by the way, see, I don't know how these menus work. You notice how every time I had to go to Google to find it. I'm still not, the interface with this thing is just a little, maybe not what it could be, but it does work. So, the weird thing, though, is that sometimes you don't see all these menu items that it supposedly has. But all right, anyway, there it is. So that helps. Okay, good. Now, how about this one? We're going the other direction. So it's going to have to be 4.098 times 10 to some negative exponent. And, what we can do again, the graphical way is to shift the decimal 1, 2, 3, 4 places to the right. So that implies that this exponent is actually -4. All right. Now, what else do we know? Another way, we note that when there are 3 leading zeros, now you notice that means zeros, leading zeros are the ones that come after the decimal point, but before the first non-zero value. When there are 3 leading zeros like that, the exponent will be -4. So in other words, the exponent will be, the magnitude will be 1 larger than the number of leading zeros. If we had 5 leading zeros, the exponent would be -6. Okay, so that's how it works. Or you can try the E approach, try the different EEs until you get to the right one, or what you could also do, note that this number that we started out with equals 4.098 times 0.0001. All right, if you're not sure, double check that on your calculator. 4.098 times 0.0001 is 0.004098. And then in turn, this is 10 to the minus 4th power. Now, if you're not sure about that, remember there's a chart in the notes, in the slides. I put together a chart that goes all the way up to the 1 millionths. So you can go double check that if you need them. Okay. Try to be consistent here with my answers. Yep, okay, we're good. So there's a lot of things you can try. Or, well, now that we know, what a shocker. It's 4.098 times 10 to the -4th. Not only that, but look at that. They're also recommending that you do the technique that I was showing you here, where you shift the decimal.
That's what I was like thinking. So. I'll put one on.
That's what you were doing.
Okay, recording.
All right. So, okay. Now, arithmetic sequence, now these are definitions. The Symbolab can't help you with these. This is a sequence with a constant difference between the terms. The key word there being difference. And here, this is a sequence with a constant ratio between the terms. Oops. That's all you need. All right, now for E, the first thing we need to note here is that this is an arithmetic sequence with a common difference of 2. All right, you can tell by looking at it right away. Therefore, what do we need to know? Well, A1, the first term, is 2, and D is 2. To find the nth term, a 10th term rather, well, first let's rewrite our formula that we know and love. AN equals A1 plus n minus 1D. In this case, means that A10 must be 2 plus 10 minus 1 times 2, which is 2 plus 9 times 2. 2 plus 18, whoops, 20. Now this one is easy to confirm because all you have to do is write them out yourself, as long as it's not an enormous sequence. And you're done, okay? Now that's up to you. You probably should use the formula, but yeah, I don't think Symbolab can do anything like this. It's not impossible. It might have sequences in it. You can look into that. Now, what about this one? Okay, let's see. So this one, what's going on with these terms? Well, this one does seem to have a common difference. With a common difference of 4. A1, the first term, is 1, D is 4. So we're looking for the sum of the first 5 terms. Now, the sum formula is a little bit trickier. A1, oh, wait, whoops. N, A1 plus AN over 2. So therefore, S5 is 5. Oh, one more thing we need to know A5. So there's a couple of things we can do. Whoops, I almost forgot. So in this case, A5, because we almost already have 5 terms, it might be quicker to just say, well, the 5th term can be found by extending the sequence by one term, 1, 5, 9, 13, 17. Okay, so A5 is 17, or by using the formula. And it's up to you again. It's always up to you. That formula, which implies that A5 is 5 plus 5 minus 1 times 4. 5 plus 4, wait a minute, what happened? Oh, no, I just copied the wrong thing, sorry. So either way, A5 is 17. Okay, so that's definitely, okay, so we're all set there. Okay, so we have everything we need. A1 is 1, A5 is 17, the difference is 4. All right, so now we can do this. So we have 5 times 1 plus 17. Divide by 2. And of course, if you want to, we can confirm this by adding up the first 5 terms. Very simple. Let's add them up. And if you add them up with your calculator, you'll see that it is in fact 45. All right, now G is a little different because G now all of a sudden is a geometric sequence with common ratio 4. So A1 is 1. R is 4. Now the formula for finding the 8th term with the geometric sequence is AN equals A1 times r to the n minus 1 power. Which means that the eighth term, A8, is 1 times 4. The exponent, since we're looking for the eighth term, the exponent will be 7. So we actually end up with, you can simplify this to 4 to the 7th power. And that's equal to 16,384. Now, if you want to write these out and prove it, that's okay, but it's a big sequence. Okay, so maybe that won't be necessary. Now, finally, we have this one, the sum of the first 6 terms. Now, this is a geometric sequence with a common ratio of 3. Okay, if you're looking at it carefully, you'll see that that is the case. So A1 is 2 and R is 3. That's all we need. Now this time we're looking at the sum. And the sum formula for a geometric sequence is Sn equals A1, 1 minus R to the n over 1 minus R. So we're looking for the first 6 terms. 2, 1 minus 3 to the 6th over 1 minus 3. 3 to the 6th is 729. So you get 2 times minus 728 over minus 2. So the 2's cancel each other out. So do the negatives. We actually end up with 728. Okay, now, as usual, we may feel the need to double check. Why don't we try that? Of course, all we're doing is adding them up. All right, so what was the original? Here it is. We only need the first 6, so this shouldn't be too bad. Now, this is purely optional. You don't have to do this. Now, remember too, this is the common ratio is 3. So the next term would be 162. And the next term would be 486. So we add them up, 2 plus 6 plus 18 plus 54 plus 162 plus 46. Why don't you add those up? And that's 728. Okay, so that's that. Well, clearly it must be right if we double checked it. And then we get to do a FOIL. We love FOIL, don't we? It's very straightforward. What's different here, though, is that if you notice, instead of the usual x's, we have an x squared in this case. So the results might be a little messier than what we're used to. Not a problem. You just have to be careful. All right. And what that, by the way, that also means that there's a very real chance that none of these terms can be combined with each other. Okay, so just be aware of that. When you have an x squared here, that does change the possible range of results. So f is 8x cubed let's see. Let me just draw this a little neater. All right, here we go. So here's f. Here's O. 14x squared. I is minus 12x. So you can see so far none of them are like terms. And then finally last is negative 21. Okay, so we're done. 8x cubed plus 14x squared minus 12x minus 21. And that's it. There's nothing we can do to simplify it. And so we're just done. Okay, great. Now this next one though, there's no x squared, so there should be some terms that combine or consolidate. So let's see how this one works out. Okay, let me just leave it there for a second so you can catch up. All right, now we're ready. So let's do FOIL on this one. F minus a positive 35x squared. O okay, O is minus 10x. Whoops, not squared, 10x. I is minus 21x. And then last is 6. So we combine these, we have 35x squared minus 31x plus 6. So just the 3 terms. Nice. All right, that was pretty straightforward. Now the next one, we've got 2x squared. So there could be some very interesting results here. All right, let's find out how that worked out. So we'll do F, O, I, L. It's negative 8x to the 4th. 4x squared. Ooh, look at this one. I is negative 12x cubed. And then finally last is 6x. Now, again, we can't combine these, but I want to point out something here. What we normally try to do is write the terms with the highest exponents first, moving our way down to the lowest exponents. In other words, the way it's written here, you could have put 4x squared second and then minus 12x cubed. And that technically is correct, but we prefer it this way. By convention, we try to have the highest exponents first, and we work our way down to the lower ones. All right, so that's that. No more foiling for today. So now let's do this. Let's do some factoring. Now factoring, you know, it's kind of a lot of work, but it's helpful. So for example, let's look at this first one. Now, what are we trying to do? We're basically reversing the FOIL operation. We're working it backwards. We have to be aware, though, that whatever we end up with, the 2 factors can be written as x plus some constant and x plus some other constant, which, by the way, these constants can be negatives. And if you apply FOIL to it, you'll see that we're going to end up with x squared plus m plus nx plus m times n. So we're looking for pairs of numbers whose product is negative 12 rather, sorry. Mn equals 12. At the same time though, m plus n has to equal negative 8. So you basically have two equations and two unknowns. Now, there's different ways of going about this, but I think the easiest way is to say, well, all right, let's look at Mn. What factors can give us this number? And now there's 6 of them, but only one of these has a sum of -8, and that would be this one. So it must be the case that M is -2 and N is -6. So therefore, the factors are written as x minus 2 times, x minus 2 and x minus 6. And if you're not sure that you've done this correctly, you can FOIL them. Oh, so you know what that means? That means we do have an excuse to do some more FOIL. Let's find out. X minus 2, x minus 4, x squared, minus 4x, minus 2x, 8. Oh my God, that is exactly what we started out with, isn't it? Oh, wait, no, something went wrong. Oh, I copied it wrong. No wonder. Oh, of course. Oh my God. After all that, I copied it wrong. This is why you should double check everything. No matter how well you know something, you can always make mistakes. Look at that. I just copied the thing wrong. Okay. Let's try that again. So that means f is x squared. O is minus 6x. I is minus 2x. And last is positive 12. Now we're there. All right. Okay. So x squared minus 8x plus 12. Now, what about this one? So based on what we just did, remember the sum is always this term. The product is this term. So we know that Mn equals 8, M plus N equals -6. What can we do over here? And of these, only one has the sum of -6. So the factors are x minus 2 and x minus 4. And again, we should double check this with FOIL just to make sure. Although this is optional on your test, you are not ever required to double check anything, but I think it's a good idea. That's what we start out with, isn't it? Yes, it is. So we did this one correctly as well. So the final answer is right here, by the way. Let's not lose sight of that. That's what we're really after. Okay. So we're zooming along now. Quadratic formula. Everybody loves the quadratic formula. All right, it's easy. It's straightforward. No problems. It's just a question of being careful with it. Most likely, I mean, if you're going to make a mistake, it'll almost certainly be with the signs. So in this case, A is 2. This is B. B is negative 12. C is 16. Okay, so let's plug them in. So minus 12 plus a minus. Minus 12 squared minus 4 to 16 over 2 times 2. So this term, 4 times 2 times 16 is 128. And so you've got a perfect square. Well, that makes things easier for us. Okay, so remember what this means. This plus and minus means we've got 2 different terms here. And so that leaves us with 8/4, 16/4, or just 2 and 4. Now, if you really wanted to, we're not going to do this right now. We're running out of time, but if you plug either one of these numbers into the original equation, you will get a 0. That's how you know you did it correctly. Okay, if you do, you don't have to, but if you want to, that's how you would do it. Okay, now, how about this one? Same idea, very similar as a matter of fact. A is 2, B is 6, C is 4, oh, I think we got, well, maybe we didn't get. I see a perfect square building up underneath that square's root sign. And that really makes things nice. So we end up with -2, -1. Very nice. Now, here we have the dreaded word problems. Now, everybody dreads these, and there's no reason for it. This one's a little tricky because, well, all right, you'll see why. Let's do this. An inventor leaves his entire estate to his wife and son. His wife gets 2/3 of the estate, and his son gets the rest, which means, of course, 1/3. If the son receives $500,000, what must be the value of the entire estate? So here's what you can do. Let's let X equal the value received by the wife. Y will be the value received by the son. We know 2 things. X is double Y. No, wait a minute. No. Oh, that's right. Yes, it is, of course. In other words, because the wife receives, this is the tricky part, 2/3, and the son receives 1/3. The wife receives twice as much as the son. Therefore, we can say that X equals 2 times Y. We also know that the son is getting $500,000. So I mean, it's pretty straightforward. Now, what you can do here, so listen, X equals 2Y And you already know, since y equals 500,000, X must equal 2 times that. Okay, so therefore, the wife receives $1 million and the son receives $500,000. So the total estate is worth, obviously, $1.5 million. And that's it. That's all you have to do. But the challenge, this was right here, right there with the tricky part. And a lot of people find that very challenging, let's say. So concentrate on the information. Yeah, I don't know what else you can do here to get ready for this, except to think about this in terms of the relationship between how much the wife receives and the son, not in terms of dollars, but ratios. And that should take care of it. Okay, so yeah, in the past, a lot of people have not done well in these types of problems. I hope that you'll be able to, if you set it up properly, you should not have an issue, because you're just really trying to turn this into a ratio. This is the challenge right here. So let's say, imagine instead they each got half of the estate. Well, then you could write right here, X equals Y. And if the son gets $500,000, the wife is also getting $500,000. So that's the part you want to focus on. All right, now what else do we have? We've done these before, haven't we? Yes. We had one of these in the slides. So we know that we have a deck, which is a rectangle. Whoops. Now, there's a couple of ways of doing this one. This one costs $21.60. And this one costs how much? We don't know. So what you could do is this. The first deck has an area of 9 times 6, which is 54 square feet, or for a cost of $21.60 over 54, which is $40 per square foot. The second deck has an area of 12 times 9, 108 square feet. Okay, so this means that the cost is 108 square feet times $40 per square foot. And if you multiply that out, you'll get $43.20. If you notice, though, also the second deck has an area which is double the area of the first deck. Therefore, it must cost twice as much, or $21.60 times 2, which is again $43.20. So you didn't have to do the quadratic equation this time, because you already know the area of the first one. You can figure out the area of the second one and the price in terms of the first one. All right, so that was a little tricky. I don't know. Now, this last one is something that everybody universally hates on these tests. I don't know why, but you know what? Let's try it. Maybe it's because you haven't seen something like this before. So here's stock X. 4% dividend. Stock Y. And if you're not that familiar with stocks, it's simply a cash payment that you receive because you own the stock. The percent refers to the percentage of the value. So for example, what they're telling us here is that the professor owns both stocks. We also own or receive $270 worth of dividends at the end of the year. So therefore, the question is, how much money does he have invested in these stocks? So let's do this. X equals the amount invested in stock one, X rather. Y is the amount invested in stock Y. Now, here's the challenging part. He's got equal amounts invested in the two stocks. It says it right up front. So we can say, oh, well then X equals Y. Well, that's easy. Now, what about this other part with the dividends? The dividend on stock X is 4% of its value, which means 0.04X. The dividend on the second stock is 6% of its value, and we know that those add up to 270. That's the challenging part right there. In other words, 4% value of stock X plus 6% of the value of stock Y equals $270. That's the total amount of our dividends. Now we can use the method of substitution as follows. And so we'll start with this one and we'll say, well, wait a minute. This is one equation, two unknowns. So why did that happen? Well, you know what I can do? Since X equals Y, we can replace Y in this equation with X. And then what happens is that Y is replaced with X. And look what happens. Oh, now that's suddenly much simpler, isn't it? Now there's one equation and one unknown, no problem. So 0.10x, the sum of those two is 270. If I multiply both sides by 10, I'll get 2,700. And since Y is equal to X, Y also equals 2,700. So the professor has invested 2,700 in each stock for a total of 5,400. Okay. Now the question actually wanted to know how much is in each stock, but if they asked you for the total, it would be easy. It's 5,400. So, you know what? I don't know. The thing is, the tricky part in this one is this equation with the dividends right there. So just read the question carefully and see what it's telling you. What percentage of each stock do we have and what's the grand total? And in addition, we need to know how much he invested, what proportion is in each stock. So like if it had been 2/3 X and 1/3 Y, we could have said X is double Y, just like we did in this problem with the father, mother, and the son. So instead it's equal amounts. So we have X equals Y. But other than that, you shouldn't have any trouble with it. All right, so this is it. We're done with this review and it's just about 12 o'clock. So I think you're ready to get started on this, aren't you? Yes, you are. I can tell, I can feel your eagerness through the screen here. So what I'm going to do, maybe not right this minute, but sometime today, I'm going to post these solutions as well as the actual test. And like I said, the clock starts today. You can have until midnight next Monday, but I don't think you'll need anything like that much time to do it. And don't forget, if you want to, you can feel free to double check your results with Symbolab to the extent that it's possible. I don't know if it's capable of doing more of this stuff, but it certainly can be helpful in certain areas. But like I said, don't try not to depend too much on it. Okay. Now, another helpful hint here is this. When you write out these solutions, you should probably don't just write the answers. try to write out the steps you followed. They'll tell you why. Because if you write the wrong answer and I know what happened, I can give you partial credits. But if you just write the wrong answer, then I can't do anything. So that's another reason why you should not completely depend on Symbolab, because you've got to be able to explain to me what you've done if you want to get partial credits. Otherwise, you're just gambling. Okay, if you just write 3 and that's not it, you can't get any points. So try to put at least some of your steps in here just to make sure I understand what you're doing. And that way I can be very helpful. Let's say you do one of these complex foils and you make a sign mistake at the end, then I can still help you out. Okay, I don't like to take away a lot of points for silly mistakes, but I have to have some work in order to do that. Okay. So just keep that in mind. And other than that, if there's no last minute questions, I guess we're done. And then I'll see you on Thursday as usual, and we'll start back on chapter 8, our discussion about interest rates. All right. So are we all set? Well, I'll take that as a yes. All right. And I'll see you all on Thursday then. Oh, there were some chats I missed. Oh, there you go. Yes, you're welcome.